Alrighty, my students, good afternoon. I know I'm making this video a little bit later than I wanted to, but I had to get everything ready, solve it, and do all that good stuff first. So I do apologize for releasing this video a little bit later today. So like I mentioned in my announcement, I'm not going to be doing the virtual lessons through Google Meets until I can get clarification on like exactly what and what's not allowed through that as far as recording or anything. I just don't want to, get in trouble or do anything I'm not supposed to. So I'll ask tomorrow at our weekly meeting, and I'll let you guys know. But until then, I'll just be recording myself through here, solving the questions, and upload to YouTube. Okay, so let's go ahead and get started. So in the questions that I assigned for you students that are due on Tuesday, this is question number 4. So I chose this one to solve only because it looks a little bit more complicated than some of the other ones. And it's, as far as like what the question is asking, it's all very similar to the other questions on the assignment. So if you watch this one, you should be able to apply what I'm covering here to the other questions. Okay, so I'll go through the 4 parts. Again, this is question number 4, and then part A. Part A is asking us to find the orders of the rate of reaction for all 3 reactants. Okay, so for this example, we do have 3 reactants. We have Br03 negative, Br negative 1, and H plus. Okay, so those are my 3 reactants, so I'm going to need to find the orders with respect to each individual reactants. Okay, so the easiest way for us to do that is to be looking at how the concentration changes and how the rate changes to reflect that. Okay, so let's start with Br03 negative 1. So the values here in the table are measured in molarity, or your concentration. Okay, so let's look at experiment 1 to experiment 2. Okay, so from experiment 1 to experiment 2 for Br03, we have 0.10, 0.20. Okay, and this is for Br03 negative 1. Okay, so that's the concentration. So as we increase that concentration, let's see what happens to the rate. So again, I'm going to be looking at experiment 1 to experiment 2. Okay, so the rate in experiment 1 was 8.0 times 10 to the negative 4. And the rate in experiment 2, 1.6 times 10 to the negative 3. So looking at the values here, we see that the concentration doubled, right? It increased by 2 times, and the rate also increased by 2 times. Okay, so since the concentration and the rate, they both doubled, that is considered to be a first order reaction with respect to Br03. So this is considered to be first order. Okay, so since these numbers are all fairly simple, I'm not going to go into the actual math involved. You can just look at the experimental data provided. Okay, All right, so one thing I do want to note before moving forward is be careful at the trials that you are comparing. So you want to compare, so since I'm looking at Br03, I want to be looking at the data where the concentration of only Br03 changes. So if you notice, the concentration for the other 2 reactants maintained or stayed constant, right? Br negative 1 stayed at 0.10, H plus stayed at 0.10, experiment 2 again 0.10, 0.10. So be careful when you're choosing your data, because you only want one reactant concentration to change at a time. Because if you're changing more than one variable, then you can't really see how the rate is affected. Excuse me. Okay, so that's for BrO3. So next, let's go to Br negative 1, a bromide ion. Okay, so Br negative 1. So again, I'm going to be looking at the two trials or two experiments where the concentration of Br negative 1 changes, but the other two reactant concentrations stay the same. So that happens here. Experiment 2 to experiment 3. We see that BrO3 stays at 0.2, and we see that H plus stays at 0.1. Okay, so Br negative 1, we have 0.10, 0.20 for the concentration, and then the rates, I have 1.6 times 10 to the negative 3, and then for experiment 3, 3.2 times 10 to the negative 3. Okay, so I'm comparing these two for Br negative 1. And again, 0.10 to 0.20, this is a 2 times increase, it doubled. And 1.6 times 10 to the negative 3 to 3.2 times 10 to the negative 3 is also a 2 times increase. Okay, so since the concentration doubled and the rate doubled, that is going to be considered a first order reaction. Okay, so lastly, let's look at H plus. So in my previous lecture, I did go into a little bit more detail on the difference between the different orders. So if you haven't watched that one, I recommend watching that one first, my students. Excuse me. So that one I did upload to Google Classroom. I don't believe that one's on YouTube, but I can maybe try to upload that one to YouTube as well, just in case it makes it a little bit easier for you all to access. Okay. All right, so now let's look at H plus. So what some students might want to do following the trend is they might see, okay, H plus increased from experiment 3 to experiment 4. So that's what I'm going to use to compare. However, we cannot do that because Br negative 1 also changed and BrO3 ion also changed. So we cannot use those two sets of data because more than one variable, more than one concentration is being changed at a time. So what we're going to be comparing for H plus is experiment 1 to experiment 4. Why? Because in experiment 1, we have BrO3, that's 0.10. Experiment 4, it stays at 0.10, so it's not changing. Experiment 1, 0.10 for bromide ion, and then over here, also 0.10, so not changing. And then finally for H plus, I have a 0.10 to a 0.20, so that one is changing. So those are the two experiments that I'm going to be looking at for H plus. So I have 0.10 to 0.20. Okay, so then I'm also going to be comparing the rates during that time. So rate for experiment 1 compared to rate for experiment 4. So for experiment 1, my rate is 8.0 times 10 to the negative 4. And the rate for experiment 4 is 3.2 times 10 to the negative 3. Okay, so looking here, we have H plus concentration increasing by 2 times. It doubled. However, the rate went from 8.0 times 10 to the negative 4 to 3.2 times 10 to the negative 3. So this one is going to be a 4 times increase. So whenever your rate increases to the square of your concentration increase, then that means this is a second order reaction with respect to H plus. Okay, So that's all part A was asking. The orders of the rate of reaction for all three reactants, which we did. BrO3 is first order, Br -1 is first order, and H plus is second order. Okay, so let's go on to part B. Part B is the overall reaction order. Okay, so then here, make a different color. We said BrO3 -1. The exponent here, whenever we're writing our rate law, I'll just do x is equal to 1, right? Br -1, y is also equal to 1 because they're both first order. And then finally, H plus, that exponent is equal to 2. So the overall reaction order is 1 plus 1 plus 2, which equals fourth order overall. So to find your overall reaction order, you add up the individual orders for each of your reactants. So for this reaction, it is a fourth order reaction overall. Okay, so let's go on to part C, the rate law equation. So again, previously we saw that the rate is equal to your rate constant K times reactant A raised to its order times reactant B raised to its order times reactant C raised to its order. Okay, so you can either have one reactant, two reactants, three reactants, or you can, or you can have, however many according to your chemical reaction. Okay, so in this case, since we do have the 3 and we're able to figure out the reaction order for each reactant, we can fill out our rate law equation. So for this reaction, our rate is equal to rate constant K times my first reactant, which is, I believe that's bromates, -1. And we said bromate is a first order, so it's going to be raised to 1. Times my second reactant, bromide, -1. Raised to, again, it's a first order, so raised to 1. Times my last reactant, which is H plus, raised to a power of 2, because it is a second order reaction. So my handwriting isn't the best on the iPad, so hopefully you guys can understand that. We have rate is equal to K, BrO3 -1, raised to the first power because it's first order, times Br -1, raised to the first order again, times H plus, raised to the second power because it's second order. And again, just so you guys remember, whenever we have anything in brackets, like this, right? Remember those brackets mean the concentration. So the concentration or molarity. So whenever we're multiplying these 3 reactants here, we're multiplying their respective concentration for whatever experiment or problem we're looking at. Okay, so just something for you guys to remember. Okay, so let's go ahead and go on to the last part of this problem, part D. So here we are going to do a little bit of a calculation to determine the rate constant, or the value of the rate constant K. So that rate constant K is specific for each reaction, and you need to have the rate law equation completely filled out in order to determine it. Or for this situation, we need to have the rate law equation filled out in order to determine that rate constant. Okay, so since we already have the rate law equation, in order to calculate for this K, what we're going to do is we're going to replace all our other variables with values from our experimental data. Okay, so let's start by rewriting that rate law. Okay, so we have our rate is equal to K BR03 -1 first power BR -1 first power and H plus squared. Okay, so we have all the information we need in our data table to fill this in. Oops. Okay, so I'm going to be using data from experiment 1, only because all 3 of the reactant concentrations are the same. So it should make the calculations a little bit easier. Okay, so when I replace my information for rate, I'm going to use the rate of that specific experiment, which is the 8.0 times 10 to the -4. So 8.0 times 10 to the -4 is equal to my rate constant K, which I don't know what it is, times my concentration of bromate, which is 0.10 molar, times my concentration of, and this is to the first power, times Br -1, which is 0.10 molar raised to the first power, times my last reactant, which is H plus, 0.10 molar squared. Barely had enough room. Okay, so now we can go and fill this out, or not fill this out, excuse me, calculate this. Okay, so 8.0 times 10 to the -4 is equal to K. 0.1 molar to the first power is just 0.10 molar. And I should be including this. This is bad form of me, so I'll put it in red. But my rate does have units, which is molarity per second or molar per second. So that's bad form of me, guys. I'm sorry. You should always be including your unit. Okay. So again, 0.1 molar to the first power is just going to be 0.10 molar. And then 0.1 molar squared, I already did the calculation beforehand. So this one is going to be 0.01 molar squared. So we squared the value and the units here. Okay, so I'm going to multiply these 3 values together so we can see what we get. 0.1 times 0.1 times 0.01. 0.1, oops, 0.1 times 0.1 times 0.01 is going to be 0.0001, or 1 times 10 to the -4th power. Okay, so let's go back here. 8.0 times 10 to the -4 is equal to K. 1 times 10 to the -4. And here, since we multiplied m squared times m, this is going to be m to the 4th power. Okay, and then my last step is to divide both sides by 1 times 10 to the -4 in order to isolate my rate constant K. Divide 1 times 10 to the -4, 1 times 10 to the -4. Okay. So then here, everything cancels out. Here, the only thing that'll cancel out is one of these. So this will become 3. So if I divide those two, 8.0 times 10 to the -4 divided by 8 times 10 to the -4, I will get a rate constant of 8. So at the end of this, K is equal to 8. You can do 8.0 if you like, but I'll just leave it as 8. And then my units. So I'm left with inverse seconds here on top, and then I'm left with m cubed on the bottom here as well. So my final unit for k is going to be 1 over m cubed times s. Okay, and that is my final value for k, my rate constant k. Alrighty, students, so I will stop there. Hopefully this will help you when it comes to solving your homework or working on your homework. You have about 5 of these types of questions to be working on. So use this video to help you. And if you have any questions, comments, concerns, you can email me or leave me a private comment on Google Classroom, and I'll do my best to answer any questions you might have. All right, thank you, my students.